Hello everyone. So continuing with our chapter environment and health, in that we have covered air, its pollution and prevention, and noise also we have covered. Now as I said that in water purification on small scale that we have not covered, in water large scale purification methods we have covered. So the question can be asked on the purification of water on small scale, isn't it? Water purification on small scale. So when limited water is to be purified, like at home if we have to purify water, so what are the methods? When the quantity of water is in few liters we can say, isn't it? Which cannot exceed uh, say 100 liters or so on. So on small scale these methods can be employed, isn't it? Now for domestic purposes the methods that are followed, first is boiling, isn't it? So actually there are total 6 methods. Boiling is there, distillation, filtration through muslin cloth, three pitcher system is there, chemicals, and then domestic filters are also used, isn't it? Like nowadays the aquaguard and Kent and all that, these are nothing but the filters are there, isn't it? So directly purified water we get, and in this the filters are uh, there, isn't it? So one by one we will see. First is boiling. Now boiling for 10 to 20 minutes, isn't it, is essential, isn't it? That kills bacteria, spores, cyst, ova, isn't it? By boiling, the another advantage is that it removes hardness also, that is the temporary hardness. Now what is hardness, that also we will discuss, isn't it? So hardness, when it is removed, we get soft water, and by boiling the taste also little bit gets altered, isn't it? Then this boiled water should be stored in same container, isn't it? These are the precautions. So boiling is the oldest and satisfactory method of purification of water, and in houses also we can purify by boiling. So whenever when some infection is there and when we consult doctor, so at the time of treatment also the water that is suggested, that is to be boiled and cooled, isn't it? So by that also the whatever the treatment is there, that is enhanced. So boiling is very important method. It is very older method. It is useful, isn't it? And it is excellent method of purification of water, isn't it? The only thing is that it is to be done in neat and clean vessel. That means whatever the utensil it is used, that must be clean. In that only it must be boiled, and it must be stored in the same container, same utensil, isn't it? And only that much amount of water must be boiled which can be used within few hours. Then the other method is chemical disinfection. So here chemicals are also used. Various types of chemical agents are there which are used for disinfection of water, isn't it? So one by one chemical I will let you know, and all these are chlorine containing compounds. Regarding chlorine also we have discussed, isn't it? On large scale we have seen the purification of method where three steps are important. First, the water is to be stored in large reservoirs. So first step is storage, then second is filtration, where we can use slow sand filter or rapid sand filter, and the third step is disinfection, or it is also called chlorination. So in that chlorine containing compounds are used. Now here also these compounds can be used on small scale also. So one is bleaching powder, isn't it? The other name for bleaching powder is chlorinated lime, isn't it? Formula is CaOCl2, isn't it? So if freshly made chlorine bleaching powder is there, so there is 33% of available chlorine, isn't it? But when it is not fresh and when this bleaching powder is stored, so it loses chlorine content, isn't it? So this chlorine percentage that varies from one compound to another, isn't it? So this is to be stored properly in dry airtight containers and at cool and dark places, isn't it? Now 2.5 gram approximately of good quality of bleaching powder is required to disinfect 1000 liters of water, isn't it? Bleaching powder directly doesn't purify turbid or polluted water, isn't it? So it must be first subjected to preliminary treatment, isn't it? And then it can be purified. The next compound is chlorine solution. Now chlorine, it can be useful available in the form of liquid, in the form of powder, or in the form of tablets also, isn't it? So chlorine solution, it is prepared from bleaching powder. 4 kilogram of bleaching powder with 25% available chlorine is mixed with 20 liters of water, isn't it? That gives 5% solution of chlorine, isn't it? And that chlorine solution can be used for purification of water. Then other compound is high test hypochlorite. The short form is HTH, isn't it? You must know high test hypochlorite. It is a calcium compound, isn't it? It is also called perchlorone. It is the stable compound, calcium compound, and it contains maximum amount 65 to 75% of available chlorine. Now this is much stable compound, and this in very less quantity it is needed to purify. Like 1 gram of high test hypochlorite is needed for 1 cubic meter of water. That much water can be purified by this compound. Then chlorine, as I said, in the form of tablets also they are available. One of the trade name is Halogen tablet, isn't it? It is good, but it is little bit costly. So single tablet of 0.5 gram is sufficient to disinfect 20 liters of water, isn't it? So the tablet that is available, it is of strength 0.5 gram, that is 500 milligram, that can purify 20 liters of water, isn't it? Then certain halogens are also there which are useful in purifying water, like iodine is there, bromine is there, isn't it? So when there is emergency to purify water, to disinfect, so iodine and bromine, they can be used, but they are not used routinely, isn't it? And they can disinfect water within half an hour, isn't it? And 2 drops of 2% ethanol solution is sufficient for 1 liter of water, isn't it? So 20 to 30 minutes is the contact period. The only thing is high cost, isn't it? The next compound which is used is potassium permanganate. Now this is a strong oxidizing agent, isn't it? And can kill many microbes also, like the microorganism responsible for cholera outbreaks like Vibrio cholera, that also can be destroyed, isn't it? This is not used nowadays, isn't it? It is you earlier it was used for disinfecting wells, isn't it? And the other thing is that it is not suitable for disinfecting large volume of water, isn't it? It alters the taste, smell and color of the water, isn't it? That is why it is not used nowadays for disinfecting water. Then other is filtration by domestic filters. Now as I said, domestic filters uh, can be used, isn't it? Certain examples are also there of these filters, isn't it? Like ceramic filters are there. In that pastures, Chamberlain filter, Bergfield filter, isn't it? Now in these filters, the main part is candle, isn't it? These are cylindrical filters, isn't it? So they are also called filter candles or ceramic candles, isn't it? They are cylindrical in shape, isn't it? They are made up of the material that is called porcelain, isn't it? Or Fuller's earth is called Kaiselgar, isn't it? Or porcelain, and they are available in various porosity grades, isn't it? Now, when water is purified through these candles, the pores get clogged, isn't it? They get blocked. So this needs periodic cleaning, isn't it? So periodically these filters can be cleaned and they can be again reused. They can be cleaned once a week also, for example by scrubbing with hard brush and then passing the water under pressure from inside to outside direction, which will remove the entangled particles from the inside space, isn't it? Similarly, Pasteur's Chamberlain filter also, so it can be screwed on a water tap also, isn't it? This Pasteur's Chamberlain filter works only under pressure, isn't it? And muddy water cannot be filtered, isn't it? So this filter also can be cleaned in same manner, isn't it? These filters are quick and reliable, isn't it? And all type of impurities can be removed, including bacteria, isn't it? So that was all about the water which is to be purified on small scale, isn't it? Now the next topic in this environment and health is solid waste disposal, isn't it? As we know that we are dealing with environment and health chapter. So in environment, the main environmental factors that are to be covered in your syllabus, that is water, air and soil, isn't it? Noise we have already covered, isn't it? Now this soil is the another important environmental factor, and regarding soil we are going to discuss under this topic, that is solid waste disposal. Now there are certain terms also which are used related to solid waste, isn't it? So solid waste means what? Solid waste means discarded waste matter, we can call discarded waste matter, isn't it? You must know solid waste means what is in Marathi kachra, isn't it? So whatever unwanted thing that is removed from the any premises, maybe residential premises, maybe commercial, maybe industrial, isn't it? Maybe public places, maybe educational institutions, isn't it? So many terms are used for this solid waste. We can call refuse, we can call solid waste, we can call discarded waste matter, isn't it? In south region, in Kerala, Tamil Nadu, Karnataka, the other term that is used is litter, isn't it? So in village areas, litter is also used. Simply we can call refuse also, isn't it? So the term solid waste includes garbage. Now garbage again, if we go in deep, means food waste. So whatever the waste food that is accumulated, that is called garbage. Then rubbish we can call maybe refuse which contain paper, plastic, wood, metal, throwaway containers, glasses, isn't it? Then demolition products, isn't it? So that will include anything, maybe plumbing material, maybe construction material, maybe PVC material, maybe metals, isn't it? Then sewage treatment residues are there, dead animals, manure, and other discarded material, isn't it? So all this will come under solid waste, or simply you can call refuse or waste matter, isn't it? Now, how this affects health? Now, this is the refuse which is getting accumulated from so many premises. At home also, when we go for dusting, cleanliness, so in that also the rough refuse material that gets accumulated, isn't it? Now it affects our health. How it affects? It decomposes and favors fly breeding, means जो मक्खियाँ पनपती हैं, isn't it? So fly breeding is the you can say process which is because of the accumulation of the refuse, isn't it? And in rainy season also you will find that there is fly breeding season. It attracts rodents, isn't it? So rats, mice, isn't it? Then pathogens may be conveyed back to man's food through flies and dust. So by mechanical transmission, our food may get contaminated, isn't it, by these flies and dust. Water gets polluted, soil gets polluted, isn't it? Then it is unsightly appearance. So many of you might have seen there is accumulation of waste matter, isn't it? Accumulation of refuse nearby to the societies, nearby to the commercial establishments, isn't it? So that is harmful to the health. Bad odor comes and it may favor the growth of microorganisms also, and there are more chances of vector borne diseases, isn't it? Now what is vector, that also we will discuss later on. Now sources of refuse, how this refuse gets accumulated, isn't it? So this waste matter refuse that gets accumulated from streets, isn't it? So many houses are there, streets are there, so many markets are there, maybe vegetable market, maybe fruit market, isn't it? Then stable litter refuse, industrial refuse, and domestic refuse, isn't it? So many activities are there that are carried out, agricultural activities are there, isn't it? And accordingly the composition of this waste matter will depend upon the source of refuse. What is collected from the street will be different from market, will be different from industries, and will be different from the household refuse, isn't it? Now, whatever this waste matter that is accumulated, isn't it? The substances, solid waste substances which are of no use, isn't it? They are thrown outside from the houses, from the shops, streets, roads, industries, isn't it? So these materials are of no direct use, but all waste products nowadays they are reprocessed, isn't it, to convert them to some useful products, isn't it? And therefore many people you will find that they are seen busy in sorting, isn't it? They collect that, isn't it? And whatever these material that is collected, they pick up all types of waste and the sorting is done, and after sorting they give it to the dealers, isn't it, who in turn sell them to the industries for reprocessing, isn't it? So here the storage of refuse is also very important, isn't it? Now, household refuse should be stored in sanitary dustbins, isn't it? So, in the figure you can see in the slide, the galvanized steel dustbin is there. Plastic dustbins are also there, which are used at home. So, sanitary dustbin must be there, which must be made up of tough material, and it must have cover, isn't it? See, this is the covered by lid, isn't it? It should be placed outside the houses, isn't it? Similarly, paper sacks can be used. Now, so many people they use polythene paper, carry bags, isn't it? Which are useful in that the refuse is collected, isn't it? And then first is collection, and then it is to be disposed of, isn't it? Now, this is public bin, isn't it? So, street and roadside refuse should also be stored in large size public bins, isn't it? And that is to be collected by the conservancy staff of the municipal corporation, isn't it? So, these public bins are used for the large number of people, and they are kept at the central place of any particular society, isn't it? And it is handled and emptied mechanically, isn't it? By lorries fitted with cranes, isn't it? Now, this refuse from the dustbins of nearby houses should also be collected in the public bins, isn't it? Now, in many Western countries also, instead of conventional dustbins, paper sacks are there. So, paper sacks are also, I gave you example, isn't it? So, household refuse is stored in these sacks, and sack itself is removed with its content from by the conservancy staff, isn't it, for destruction or for disposal far away from the habitat, isn't it? So paper sacks also can be used, isn't it? And this method of refuse collection is very popular, and in India also it is followed in some cities, and in especially in hospitals it is followed, isn't it? Now, this was about the storage and collection, isn't it? After that, see how it is to be collected and how it is to be transported, isn't it? Regarding transportation also, nowadays you know, isn't it, about ghanta gadi, isn't it? So, proper collection is very important to avoid spread of infection, isn't it? So, the collection of this, whatever the refuse is there, for that there are certain factors which are important, isn't it? So for that it depends the number of persons, vehicle available, funds available, isn't it? That is important. These factors are to be taken into consideration, isn't it? And house to house collection is there, isn't it? Then it is to be transported, isn't it? The refuse after collection must be disposed of. Disposed of means vilevat lavane, isn't it? In such a way that it will not create any trouble, isn't it, to the people. In that fashion, it is to be disposed of. And therefore, in this, the methods of refuse disposal are very important. So this question is very important, and it is asked repeatedly that what are the different methods of disposal of refuse. 5 important methods are there, isn't it? You must know that names first. First is dumping. Dumping is the first one. Then control tipping is the second one. Then this is about tripping only. Then burial is the third one. Compositing is the fourth one, isn't it? That mechanical is there. And then incineration, that is burning, isn't it? So these 5 methods we are going to discuss now. Now dumping, the refuse is dumped in low-lying areas, isn't it? So where the low-lying areas are there, away from habitat, there whatever the refuse is collected, that is carried in the vehicle, closed vehicle, isn't it? And it is dumped over low-lying areas, isn't it? Now this is the method which is simplest and easiest method, isn't it? Now when this area, low-lying area is filled, it is leveled and covered with earth, isn't it? So by this what will happen? Ki by dumping the whatever the low-lying areas are there, they are filled, and other thing is that they are used for agricultural purposes also for after considerable time period, isn't it? So these whatever the refuse is dumped, that is finally to be covered by earth, isn't it? As a result of bacterial action, refuse decreases considerably in volume and is converted gradually into manure, or it is called humus, isn't it? And this low lying area can be used for agricultural purpose also, or it can be used for residential purpose after couple of years, isn't it? But it must be very important here to note that indiscriminate dumping will be harmful for the public, isn't it? Because if it is not done properly, if it is not covered with earth, so in rainy season, in summer season, it will give offensive gas, isn't it? And it will act as a breeding place for flies, rodents, pigs, stray cattle, isn't it? Isn't it? And that will be harmful for the health, and that will also pollute groundwater as well as air also. So that was about dumping. Next is controlled tipping, isn't it? It is also called sanitary landfill. Now here in this method, the trenches are there, isn't it? See how the trenches are dug open, isn't it? So it may be 3 feet or 6 feet also. The land is open, isn't it? The refuse is put in these trenches and finally it is covered with the earth, isn't it? Now it is left this as such after covering with the earth for 6 months. During this period, bacteriological changes take place, and this whatever the refuse is there, that will get converted into manure, isn't it? And this manure can be used in agricultural fields, and again these trenches are repeatedly or can be subsequently used, isn't it? The earth which is used to cover this finally, isn't it, prevents the escape of gases and spread of refuse by air, isn't it? And by this the flies, insects, rodents will not get attracted, and there will be no any air pollution or soil pollution. So see how the trenches are dug open, isn't it? A long trench is dug open, isn't it? So it may be 6 to 10 feet, isn't it? Or you can give it in meters, 2 to 3 meters, isn't it? Depending upon the local condition, isn't it? So the refuse is filled in this, and finally it is to be covered with earth. Then next is burial. Now the difference between burial and control tipping is very small, isn't it? The only difference is that burial method is used when very small amount of refuse is to be disposed of, isn't it? So when the quantity is very less, isn't it, that at that time burial method can be used, or when it is to be used for short period, isn't it, as in camps, isn't it? Then the next important method of disposal of refuse is compositing, isn't it? Now compositing is a method, isn't it? It is a process of converting organic matter into manure. Manure means khat, with the help of bacterial action, isn't it? This method is used in some cities and towns where refuse is disposed along with human excreta, isn't it? So it is a method of combined disposal of refuse and night soil. Night soil or it is called human excreta or sludge, isn't it? So organic matter, bacterial action, this is how the process will take place in compositing, isn't it? So in this what happens, the trenches or pits are there, isn't it? The refuse and human excreta are put in the trenches in alternate layer, isn't it? Like 6 inch will be of refuse and 2 inch will be of night soil or human excreta. So this pattern is followed, and uppermost layer always will be of refuse. So when the trench is completely filled, it is covered with earth, isn't it? After this, it is left for 6 months for compositing, isn't it? 6 month time period is required, isn't it? In this 6 months, the bacterial action will take place, isn't it? The bacterial action uh, takes place, and there is the temperature rise, isn't it? The temperature may go up to 60 degree also, isn't it? And at that temperature, all harmful microorganisms, pathogens, isn't it, they are destroyed, isn't it? And these trenches, they cool down, isn't it? And they are opened, isn't it? And we get stable humus, or it is called manure, isn't it? Which is used for agricultural purpose. Now in compositing, this can be done by mechanical process also, isn't it? Now in compositing, we have seen that a period of 6 months is required, isn't it? But in mechanical compositing, the period that is required is only of 4 to 6 weeks, isn't it? This is the advanced method of refuse disposal, isn't it? Here what is done is, whatever water insoluble or large size particles are there, substances are there, like rags may be there, metal, glass, stone, bones, they are sorted, they are size reduced, isn't it? By machine. Size reduction is done, isn't it? And this size reduced refuse is mixed with sewage containing human excreta or night soil, isn't it? Mechanically they are mixed and they are subjected to incubation, isn't it? So in this process, mechanical and bacteriological decomposition takes place, and this process is complete within 4 to 6 weeks, isn't it? And the compost so form is again used as manure, isn't it? So in big cities there are large compositing plants also, isn't it? As you can see in this slide, isn't it? This is a compositing plant. Then the last method in this is incineration. It is also called burning. Burning is one of the best method of disposing of refuse, isn't it? Where sufficient land for pits is not available for dumping, isn't it? This process is also known as incineration, isn't it? Burning and incineration, it is one and the same. And the equipment required for this is called incinerator, isn't it? So burning is more suitable for disposing hospital refuse, which is generally more infectious, isn't it? And in this hospital refuse, there may be various types of discharges, blood, dead tissues of patients, isn't it? And therefore they are to be burnt in incinerator. Now here this refuse hygienically can be disposed of, isn't it? Okay, then hospital refuse can be disposed of by this method, isn't it? Incineration is practiced in several of the industrialized countries, isn't it? So in many countries this is followed, isn't it? Now there are certain things which cannot be burnt by this method, like say for example, if the refuse is containing pieces of glass, metal, sand, isn't it? Then it creates problem, isn't it? But all otherwise this method is a good method of disposal of refuse, isn't it? The disadvantage is that कि there is direct loss of manure. By this method we don't get any manure, then it is an expensive method, isn't it? Incinerator is required, and in rainy season this may be not effective, isn't it? So here we finish up solid waste disposal topic also, isn't it? Thank you.